Hello, today is Friday, August 2nd, 2019, and this is a meeting to discuss Cluster API v1 Alpha 2 and a pivot gap analysis to decide if we want to put effort into fixing pivot for v1 Alpha 2 or if we want to instead focus our efforts on the cluster ADM or whatever it ends up being called operator. So as you can see, I have a blank document here where I figure we can gather notes. The link is shared in Slack and on the two related GitHub issues. So I am going to turn this over to Jason and or Andrew and let you all kick it off.
Yep. So if we want to start talking about high level, do we want to start identifying the high level functional gaps that we have for cluster cuddle itself to start with?
Or go ahead.
I was gonna say, like, maybe. I mean, like, from our perspective, like, we don't necessarily have any love for cluster cuddle. Like, we use it purely for its pivot functionality. So when, like, you know, if there's a world where cluster cuddle isn't really involved at all, so I don't know, what's the right order of operations.
Maybe we start with just listing out what is currently pivoted for v1 alpha 1, and then we can have a similar section for v1 alpha 2 to talk about what some of the new resources are that might potentially need to be pivoted. Okay, so we do the 5 main data types, and then it also orchestrates the controllers, CRDs, and whatnot, right?
Yep.
Sort of. It doesn't actually do a migration per se. What it does is it applies the supplied provider components.
Yep.
Right.
So I think, and there's another key distinction too, and it's not necessarily just about moving the data types and deploying the provider components. It's also, right now, the pivot functionality also ensures a specific order of operations for maximum safety during the pivot as well.
Yeah.
All right, so we have a order of operations just roughly listed out.
So
is that worthwhile?
Yeah, I think so. So the first thing is obviously we scale down the controllers in the kind of source cluster.
I can take notes for you if you want, Jason, while you're talking.
Yeah. So today we do that in a relatively naive way, and we assume that the controllers are deployed via stateful sets. And because we have a copy of the provider components YAML, we basically walk that provider components YAML, find any stateful sets in there, and use that to determine the name and the namespace of the controllers that we need to scale down.
Is that accurate?
Yes, and the main reason why that's important is that when we deploy the provider components in the target cluster, and when we start migrating components, we don't end up with competing controllers fighting over those resources.
Okay.
Now, the second operation that we then do is we deploy the provider components to the target cluster.
Okay.
And then the third thing is and here's where it gets sort of complicated, because the way that we try to ensure that we do everything properly for all of the use cases that exist for Cluster API today, we actually end up walking kind of the dependency tree for clusters, machine deployments, machine sets, and machines in a particular order. So first, we look for all clusters that exist in the source namespace. And then for each of those clusters, we try to find the machine deployments. For each of those machine deployments, we try to find all of the related machine sets. And for all of those machine sets, we try to find all the related machines. And then we go back for that cluster and we try to find machine sets that aren't associated with the machine deployment and all of their related machines. And then finally, any individual machines that belong to a cluster that don't belong to a machine set or a machine deployment. And then what we do for that is we start by creating the cluster resource in the target cluster. And then we start, basically in that kind of order that we did, we deploy first the machines, then any machine sets, and then any machine deployments.
Is it all machines or just the standalone? I guess it would be all of them, right?
Well, so we go through in an iterative fashion. So when we're iterating over the machine deployments, we only copy over the machines that belong to the machine sets that then belong to the machine deployments. So we do it in that order so that we can start deleting some of the target or the source cluster resources when we know that all of their dependent objects have already been copied over. So we don't delete a machine deployment from the source cluster until we've created all of the machines, all of its related machine sets, and all of the related machine deployments in that order, so that as they're reconciled, we don't attempt to create any additional resources in the target cluster.
Right. So machines first, then machine sets, then machine deployments.
Right. But then we go through the next layer of the next layer of loops, which is then for machines that relate to machine sets, we create all the machines and then the machine sets for those, and we delete the resources as they're cleaned up. And then finally, the individual machines are the last.
I mean, could it be simplified just to do all the machines, then all the machine sets, then all the machine deployments, and then turn on the controllers, like spin up to scale to 1?
We could. The idea behind why we do it in an iterative fashion like we do today is that we could potentially enable some type of a rollback for a scenario where we end up not being able to create those resources for some reason or another.
So it sounds like this isn't 100% accurate, what I have highlighted.
Yeah, it's because we do all of the machines, machine sets, and machine deployments that are related to a machine. We go through for each machine deployment, we migrate all of the machines that belong to the machine sets for each machine set, and then, migrate each machine set over, and we only clean up all of that after, those objects have been migrated over.
So for each machine deployment, you migrate all the machines. Do you then do the machine sets?
Well, for each machine deployment, you iterate over all of the machine sets and then migrate all of their machines.
So should I just move that up here?
Yeah, probably.
Okay. So it's create the cluster in the target cluster for each machine deployment, and then like in here it would be create in target cluster.
Exactly.
And then you would create what's really for each machine, create in target cluster, and then after we've done all the machines, you'd create the machine set, right?
Correct. And after all the machine sets are created, then we create the machine deployment.
Yeah, so this is largely copy and paste for the rest of this, but I'm just going to type it out.
And then the last bit is we delete those. We delete those objects once that whole thing has been migrated. But if we don't, if we're looking for essentially the same functionality where we don't have the ability to roll back, similar to how we have today, we could easily simplify it to just migrate all machines, all machine sets, and then all machine deployments. And we'd essentially have the same behavior. It would just be harder to, implement any type of a rollback if we needed to.
I don't necessarily want to potentially remove functionality, but this seems fairly complex. And what I had originally typed, doesn't allow rollback, but it's a lot easier to code, right?
Yeah, no, I agree.
Are we also assuming so what we're describing here is the pivot phase, basically, that is in cluster CTL right now, right?
Yes, correct.
So there's kind of like a notable difference between everything that pivot phase does and what can be expected from a pivot on a cluster CTL create cluster because of the order of operations that cluster CTL takes to do a pivot. So basically, I guess I'm trying to figure out, do we always want to enable a cluster to be pivoted at any time or only during its initial bootstrap? Because it's much simpler if it's only during the initial bootstrap, because you just get one control plane machine, make sure your API server's ready, and then just fire it off.
I would think that would significantly simplify pivot. And I know, Jason, you've been involved with pivot a lot longer than I have.
So the downside there is, how do you so the complication comes in is, cluster CTL was originally meant to bootstrap kind of a quote unquote management cluster, which could essentially just be a single defined cluster that is self-managed. But the problem comes in is when you try to basically do the functionality of cluster CTL delete, which is, unroll, a created cluster, if you can assume that it's just a self-managed cluster, it's kind of greatly simplified. But how do you move those components? How do you migrate a management cluster from one cluster to another is where the complexity really comes in.
So it's the deletion flow that really matters.
Yeah. Now we could potentially simplify that deletion flow in that, if we're only looking at that deletion flow and not looking at a full pivot, as in migrating a full management cluster, we could delete that workflow by basically deleting any machine sets and machine deployments that exist, going down to just the control plane instances for the machines. And then the pivot's greatly simplified in that you only have to migrate the dependent objects for those to be able to delete that cluster.
Yeah, I think, so just to kind of highlight our bias in this case, the way that we use cluster CTL is we have 25 plus clusters out there in the wild right now that were all created by cluster CTL and all pivoted. And we don't really expect a cluster API deletion flow to go very well for us, basically, because we have no mechanism for managing the deletion. So we have a completely external script that just goes and purges a cluster's resources in our AWS account. So we have an issue where we want self-managed clusters, but we want to know which self-managed clusters are out in the wild. So the way that we do that is we have our own CRD in a management cluster that just like lets us know that a cluster exists. And we use that CRD to like establish connectivity to the self-managed cluster. So basically we have like a conflict where like the idea of an operator is super cool because you can theoretically pivot a cluster but retain a receipt of its existence. And like that's the kind of like that's the end goal functionality that we have hacked together right now. So like we only need to pivot to that end. Now, if there are like, you know, advanced use cases where we want the ability to pivot a cluster at any time, you know, the scope changes dramatically.
I think it comes back to delete. And I think given that there are multiple providers, of course, in the Cluster API ecosystem, there's no singular script that is going to cover all the cloud resources or whatever. So I think from a user experience standpoint, we need to be able to allow people who provision clusters, machines, machine deployments, and so on using Cluster API that result in cloud resources that cost them hourly money, that we need to have a good user experience so they can tear all that stuff down.
For sure.
Yeah. So if we can put the constraint that control plane instances must be managed as individual machines, of course, if they're managed at all, then we can easily simplify the delete scenario by cleaning up any machine deployments and machine sets that exist. We can clean up kind of everything outside of the control plane instances, and then that would simplify the pivot and would actually make the pivot safer than it is today, because we would only then have to basically quote unquote pivot the minimal amount of resources. One thing that I'm not sure that we have a way to identify right now, though, is if for some reason somebody created the pivot or created a cluster using the pivot and then proceeded to manage other clusters instead of just a self-managed cluster, how do you identify which of those clusters is, you know, the self-managed cluster versus the additional management clusters? Because then you can go ahead and you can basically clean up any non-self-managed cluster prior to pivoting back for deletion as well. And that would be a much safer operation than trying to migrate all of those resources and handling the deletion, you know, post-pivot.
So sorry, I was typing when you said that. If I heard you correctly, for a managed cluster and the resources that belong to a management cluster, it's easy to clean those up because you can just cube control delete them. But for a management cluster, we need to pivot, right?
Yeah, well, any cluster that's hosting the cluster API resources, if it's either a self-managed cluster or a self-managed cluster that is also a management cluster for other clusters.
Right.
Yeah. So, yeah, that's where it gets tricky. And that does highlight one thing that I did kind of skip over with kind of how we traverse the dependency tree. And we basically discover all of, you know, all of the clusters and all of the namespaces and do all that to be able to handle that kind of self-managed management cluster where additional resources are being created prior to trying to delete it.
I want to take a quick pause here and say hi to Jenny. I don't know if you've got anything in terms of use cases or comments, but please feel free to share if you do.
I'm mostly just tagging along, so it's like a fire hydrant. Eventually I'll get wet.
All right, fair enough. So anything else that we want to talk about in terms of v1 alpha 1 and order of operations and what's pivoted, or should we move on to alpha 2 and speculation?
I think moving on is fine.
Okay, v1 alpha 2.
Oh, actually, there are a couple of other things that I glossed over on the v1 alpha 1 pivot. One is machine classes are in there as well. And the way that that's handled, just to be able to handle the kind of dependency graph that we could have, is basically all machine classes are migrated over before the other resources, and they're deleted after everything's migrated over on the source cluster to ensure that those are handled right without having to try to basically build the entire dependency tree of everything that depends on a machine class.
Although we don't have those for alpha.
And what was the other one? Right, exactly. That's not going to be an issue there. There was something else and it slipped my mind at this point. We can go back to it if we need to.
I realized I don't have this documented. Where are the deletes in here for when you delete machines and machine sets and deployments and whatnot?
So individual machines are deleted after they're successfully created on the target cluster, and that's everywhere that creating them in the target cluster is.
Like right here?
Yeah. And then after all of the machines related to a particular machine set are migrated over and the machine set has been created in the target cluster, that's when it's deleted on the source cluster. And then the same thing for the next layer up for the machine deployments.
Okay. So what I'm typing now is accurate.
Yeah, and the big reason for that is that because rollback hadn't been implemented yet, what is the safest way that we can then potentially bring back up the resources, have them managed, where they are still properly defined, and then potentially with a minimal amount of manual cleanup to ensure that you're not double reconciling things. But yeah.
Okay, thank you. So v1 alpha 2, we have new data types that can vary per provider. So we know that we're going to have a bootstrap CRD or multiple. We're going to have cluster infrastructure CRDs, machine infrastructure CRDs. And what we have done for now is we have created new API groups, which is bootstrap.cluster.x.k8s.io. And then these fall under infrastructure.cluster.x.k8s.io. Oops. And we have set up the RBAC rules in Cluster API to be able to work with resources that belong to these two groups. A bootstrap or infrastructure provider could choose a different group, but if they do, they'll have to generate custom RBAC for Cluster API so that its controllers can work. So one thought, given that we have API discovery in Kubernetes, is that if we want to be able to pivot these things, we could have Cluster Cuddle deal with these two API groups by default and just enumerate every single thing that falls into one of these two groups and read them from the source cluster and create them in the target cluster. If we wanted, we could also provide flags to Cluster Cuddle so that users could either override or change or specify additional API groups that they need to pivot. But if we do want to pivot for Alpha 2, we need to handle these three different types of CRDs that are new.
So I don't think we necessarily have to use discovery. I think we can basically infer those objects from walking the dependency tree.
That's true.
From the object references. Now, the downside to that is if for some reason there are resources that are created that aren't attached to cluster API higher level types, then they would potentially be orphaned by a pivot that did that.
But that's where discovery would help. Like if you basically tell the provider authors, if you want to participate in Pivot, all of your resources must be in this group or that group, or if we add a flag to cluster cuddle, like in whatever group you specify. And if you happen to use extra groups, we're not going to pivot that stuff.
Yeah, well, and the complication is going to be with the API groups in particular, is that only providers that are sub-projects of Kubernetes SIGs should be using the x-kates.io API group. Anybody who's creating their own third-party, non-affiliated provider, they should be using a different API group.
SIG life cycle okay.
So the other thing is we've also added in v1alpha2, we're also adding new type, or not new types, but new named config maps for things like the kube config for the cluster and things like that. That right now we assume that in v1alpha1 that any of those things can be recreated. I don't know if that's necessarily going to be the case for all cases of v1alpha2.
For the config map, were you thinking of the kube config secret or something else?
Yeah, that's what I meant. Sorry.
Actually, I'm going to put in here secrets used for CA certs keys, e.g. KubeADM Bootstrapper. So what I just wrote, I know that the KubeADM Bootstrapper is still in development, but given that we had a bit of a security issue with Kappa storing the CA certs and keys in, not in secrets and just in the spec, one thing we want to do is move to secrets for things like this. So maybe we need to label things that need to be pivoted. I don't know, because otherwise, like, you know, this is a secret. It's not in the infrastructure.cluster.x-kates.io group. It's core v1.
So I think one of the benefits that we may have if we start talking about cluster ADM and the operator that's being built for that is there already needs to be some sort of plugin model for the providers so that the lifecycle management can be handled for the provider, quote unquote, provider components for each provider. Things like the CA certs and keys that are used by the KubeADM Bootstrapper, how to pivot those things could potentially be handled by kind of the KubeADM Bootstrapper plugin to the cluster ADM operator.
Yeah, I was actually thinking about that yesterday, and one thought that I had was potentially just using CRDs to request a pivot, and they would be provider specific. So you could, or maybe like we would have like one type of CRD and the providers would watch it or something, I don't know. But basically, if you want to handle a pivot and you're Kappa or CapZ or whatever, you could, the operator could create a pivot request, and then each provider could handle its own resources, like you were saying. So it's less of a plug-in model and more just.
And I just remembered the thing that I forgot about v1alpha1 from earlier, and that's one of the things that the v1alpha1 pivot does today is that when it pivots before it creates the resources in the target cluster, it cleans up any of the owner references that are there that are referencing objects that may have changed on the target cluster versus the source cluster. And it allows those to be recreated it expects those to be recreated by the controllers post-pivot. But it also sits there and it will clean up any known references, resource references, to make sure that it's not referencing something from the source cluster, like the UID from an object in the source cluster, because the UID changes when the resources move to the target cluster.
So that sounds like it expects the controllers to do adoption everywhere, right?
Yeah, exactly.
Okay.
That I mean that config, or I'm sorry, the CRD pivot request flow is particularly interesting to me. I mean, is that something that we would see come up as part of making the operator, or could that exist regardless of the full operator?
So it's an idea that I literally had yesterday, but I do think that it certainly could and should exist per provider and doesn't require the operator to function. The operator would just orchestrate it. But I have not socialized this idea other than with the three of you.
So the one worry that I would have there is because we have object references that are going across these different layers, we need to make sure that those object references are handled properly across the pivot. And how do we handle the case of pivoting the provider resources? Like, what's the ordering there? Do we pivot all the provider resources first and then the cluster API resources? Do we end up with a case where we break our assumptions of those references existing and the objects that they're referencing existing? Do we kick off any type of workflows that should have already, that we already expect to have already run incidentally during that kind of pivot process if they're being handled independently at different layers?
So speaking entirely off the cuff, I would expect that the provider should be able to pivot all of its custom resources without any action happening, especially if the owner refs are cleared, because the way that we are writing the providers for Alpha 2, although it's not documented in any sort of development guide yet, is that the providers should only do work if the owner ref is set back to a machine or whatever, or cluster, which are basically the two ones that matter. And so you could have the provider pivot all of its things first and then have cluster API pivot machines and clusters and whatnot.
The downside there, though, is we have actions, we've defined actions in the common controllers that follow the references to those provider defined components to be able to copy data from status. And if we go through and pivot all of those resources to a different cluster, then we potentially end up with issues during that reconciliation process if we don't also clear those.
Oh yeah, I'm saying we handle that.
Yeah.
And also, would there be a concern, part of the pivot flow right now is that scale down, basically preventing two controllers from doing the thing. Would there be a concern with, like, if you have a management cluster and you're trying to pivot something off of it, You know, how does that work?
Sorry, I'm taking notes. So Jason, feel free to answer.
Yeah, I don't entirely know.
Yeah, I mean that's a tough one, because like if you have a management cluster, you like, unless, you know, as a user you are okay with, you know, I will not be able to manage any of my other clusters while anything is pivoting, you know, there's.
Andrew, could you state that question for me so I can get it
Sure.
right?
So part of the current pivot flow is to scale down the controllers so that there aren't two controllers operating on, you know, the same objects. In when a pivot is driven by one of the controllers, like, how do we reconcile that? Is there a way that we can like lock a cluster, you know, basically say like, you know, while this is pivoting, you certainly can't like add machines to it, or, you know, things like that. Just how does that work?
So I think one of the options that we potentially have here is we could probably leverage some type of predefined annotation that we could use to say that this object is being pivoted, and basically treat that as a do not reconcile this object across, you know, all of the layers of cluster API. And
Yeah.
that would potentially get us out of having to worry about scaling up and scaling down controllers across the target clusters.
Yeah, that sounds pretty clean.
Now, the downside there is that that wouldn't prevent somebody from attempting to scale an object. So we would probably have to associate it with some type of an admission webhook to ensure that if that annotation is set, that we don't allow mutation of that object at that time.
Yeah.
I like that idea. We should add a validating webhook that forbids modifying the CR in the source cluster while it's being pivoted. Although we'd have to allow, I guess once it's being pivoted, the only operation you could do after that is delete, right?
Well, yeah, so the one thing we could do is, and this would actually solve one of the complications of deleting objects during pivot too. So in v1alpha1, we actually have to clear the finalizers on the source object to be able to delete it, to avoid deleting the underlying resources. So what we can do is basically, as part of, you know, we could allow the delete, and then, well,
if the annotation's there, just don't like clear the finalizer and you're done.
Yeah, exactly. And then part of the actual pivot action, when it creates a resource on the target cluster, we just need to make sure that it removes that annotation as part of that create process, or otherwise we're going to trigger the same kind of behavior there. And that's, we want to be able to have the adoption work, and we want to be able to have the reconciliation work as soon as it hits the target cluster, I think.
Yeah, I mean, I think that's just part of the workflow. I don't think that's a problem. I think we just do that.
Yeah.
Yeah, and it seems like everything, like in this current set of bullets, like we could do this with cluster CTL or with the config map kind of deal, right? Like I don't think either. I think this works either way.
What do you mean? Which config map thing are you talking about?
So like this, the annotation could be a way to essentially remove our need to scale down the controllers during a pivot. So cluster CTL could still be our pivot tool, you know, or this, you know, some kind of pivot request config map. Like either of those solutions works with this kind of annotation flow.
I like the idea. So let's pretend we've got this annotation in place. And I'm going to skip over pivot request for now, because we'll have some code somewhere that does pivoting. So I think it's basically stuff like this. So what are we pivoting, especially things that are not part of the API groups that are from the providers, so secrets, config maps, whatever. How do we identify all of those things, I think, is a remaining challenge, if not the remaining challenge.
Yep.
So
one of the things I wonder, because right now you can basically go through all of the high-level objects that exist in Cluster API v1alpha2 today, the clusters, the machines, the machine sets, and the machine deployments. Machine class does not fall into this, but those 4 main objects, we could basically query the cluster using the label today, assuming those objects are owned by a cluster. We could probably add as a requirement for v1alpha2 that any related secrets like the kubeconfig secret or those CA certs and keys also retain a label related to the cluster name, and that could potentially be a way for us to query all of the resources that are associated with that cluster.
Yeah, so it's very easy to go through API discovery and find everything that's got a label across the entire set of APIs and groups. So we could definitely do that. I am going to propose for Alpha 3 that any that cluster become required for everything involved in Cluster API, mainly because infrastructure ref on Cluster is optional, and it's not a burden, in my opinion, to create a cluster object to tie everything together if it literally is just an empty object in certain provider cases. But I think it's hopefully fair in Alpha 2 to establish this as a convention, and if you want to take advantage of pivoting, then you do this labeling.
Now that said, I don't think there's anybody today that is using the pivot workflow that does not have a defined cluster object.
I don't see how you could, right?
Because cluster cuddle generally assumes that you're defining a cluster. You have to pass it as a parameter. So having that be a requirement for pivot, I do not think would be,
Yeah, I'm not overly concerned, and I don't think it's too overreaching to say we're going to do this.
Yeah.
I guess I've never thought of using Cluster API in this way. So there are users that just make machine deployments, and that's how they use Cluster API, or?
So OpenShift, for example, only uses machine sets and machines today. They are looking to adopt machine deployments. My understanding for Cluster is that they have another way to get OpenShift installed. And so they, at least today, don't have any plans that I'm aware of to try and use Cluster API to go from 0 to OpenShift. But they are interested in, once you have OpenShift, using Cluster API to scale out worker nodes.
That actually makes sense to me, because I just realized I haven't heard about an OpenShift bootstrap provider, right? But they're doing something out there.
Yeah, so I imagine there will be one.
So another example is the Gardener project today. They're also only consuming the machine aspect of the API right now as well. But what they do is they have other tooling that spins up the control plane for them, and they have a pod-based control plane that actually lives on their management cluster.
Oh, I see.
So there are other use cases where there are folks that are doing other types of management, or I know the Linode folks are doing something very similar as well.
All right, so I think a combination of either or really all of looking at the API groups, using a label, walking what we have as object references should be able to identify everything that needs to be pivoted, right?
Yep.
So if we wanted to actually do this for Alpha 2, Jason, I'm going to look to you since you wrote the bulk of the pivot code. How large an effort is it to do this stuff, excluding pivot requests?
Yeah, so I think it's something that we could probably accomplish within maybe like assuming dedicated time, like a week or two, I think. The bulk of it is generally testing and
Right.
hitting edge cases and iterating on that, because it's, you know, it's not a quick iteration on the test process for this. But it's not a massive amount of work.
If we simplified things, so rather than doing all of this that I have highlighted right now, I don't know if this would need to be multiple passes or a single one, but we get the annotation added, and we use API discovery and the labels, and we go find everything that needs to be pivoted, and we add some logic for ordering. So we make sure that we pivot, machines before we do machine sets, for example. And maybe we don't even spin up the controllers in the target cluster until all of the resources have been pivoted. Could that, so if we cleared out all the owner refs and we got the object references fixed, so assuming all the pointers are either updated or will be updated through adoption, could we just lift and shift everything that's in all of the custom resources from the source cluster to the target cluster and then spin up all the controllers and things just work? Or is it not that easy?
It depends. I mean, ideally, we would be able to just lift and shift things, but I suspect there's going to be some type of implicit ordering that is going to impact us.
Because I think that would, if we could do that, it could greatly simplify how much code there is for pivoting.
But at the end of the day, the workflow that we talked about assumes that if certain things are marked as ready and those fields are going to persist over, that it expects the related references that it can follow to exist and all of that stuff. So we may need to, we could probably simplify the pivot case if we make sure that the controller logic we're building is able to gracefully handle those things not existing for some period of time, for the purposes of surviving, a naive pivot process.
So I want to say, let's have an action item to examine a specific pivot use case, such as, cluster plus AWS cluster, or machine plus kubeadm config plus AWS machine, and see, specifically what I'm looking for is how, when, where do we manipulate the owner references.
I would also add the kubeadm bootstrapper in there as well.
That's what this is.
Oh, yeah, sorry.
And I think if we look at that and how do we make sure the target cluster controllers just adopt and don't create anything new, I think if we can answer these questions, then hopefully we can come up with controllers that are smarter and a simplified pivot.
The one other thing that I would add is the references to secrets as well.
All right, so
because like specifically like the kubectl secret is going to be used by, you know, the validation of the node object and all of that fun stuff. I don't think the CA secret and all of that stuff are going to play into too much during the pivot, because the bootstrapping data should already be generated.
But you need the secrets if you're going to create new machines, right?
Right, but it shouldn't impact pivoting an existing machine.
Right, it would just affect future operation of new resources.
Right.
All right, so these are the couple of the scenarios here, and then what to look for. And I think if we do this analysis, then hopefully we can come up with a nice design that should be pretty clean.
So it's worth mentioning before we run out of time that our team's focus basically for this month is getting our tooling to work with v1alpha2. So that means, you know, contributing upstream as needed. So we have, you know, quite a few people. Our team is 10 large. So like whatever we can do, like if you want us to jump into like, I don't know, making this work probably relies on like the whole thing kind of working, which I don't know if it's like, I don't think the Bootstrap provider is like fully rigged up yet, right? So
no, so Chuck is, I think he's gotten the Docker provider to a state where he can pause on it and then shift his focus back to the Qbdm bootstrapper.
Yeah.
And I know Fabrizio has a plan for how to allow the Docker provider to consume cloud init output from the Bootstrap provider and translate it to doing things inside of a Docker container, which is pretty awesome.
Yeah,
so what I have wanted to do for the past week, but due to illness and other things have not been able to do, is make sure that the backlogs for the Bootstrap provider and Cappy and Kappa are sufficient so that people like those from your team, Andrew, can come in and help. So it's not just like the same 2 people or 3 people working on things. So feel free to reach out to Chuck, given that he's largely in charge of the Bootstrap provider right now. I think Cappy and Kappa, I mean, pending testing, which hasn't happened because there's no Bootstrap code that works yet. Cappy and Kappa should be in a good state, theoretically. Like all of this, the code has been updated for Alpha 2. So it's really just once we get a bootstrapper, see what's going on. Although we could probably manually generate some bootstrap data and send it over and like not use a Qbdm bootstrapper, but just combine Cappy and Kappa and see what happens. Nobody's done that to my knowledge yet. So any testing
that would just be like populating bootstrap data, right? Like basically more or less.
I mean, like spin up a Kappa v1alpha2 machine, extract the bootstrap data. It would need to be modified a little bit because actually no, it wouldn't. If you're using an image that's got the cloud init fork, you should be able to just use that bootstrap data straight up. You might have to modify like the control plane endpoint or something, but yeah, I mean, that would be helpful for somebody to test that, because I'm sure that we didn't get the AWS cluster and machine controllers right on the first try.
So one of the things that I like about what we talked about for kind of the naive approach, if we can build unit tests around the code to ensure that it handles the missing references properly for the pivot scenario. And then we can take some of the EDE work that I'm doing right now for the release 03 branch, and should be able to actually build a fully automated kind of pivot test using that, where we actually pivot the resources to an AWS managed cluster, pivot them back, and then clean things up through deletion.
I think that's a really good idea.
And if we do accidentally, we do fail that scenario and we accidentally orphan resources, the janitor would clean up those resources for us, and it would
In ED test, you mean?
Yep, exactly.
All right, so I think given that we only have 5 minutes left, there's not much time for new topics. So I will ask Andrew, since you said you have about 10 people, may have some time, do you think that you all could look into this action item, or do you need us to deal with it?
No, yeah, we can look at this. No problem.
Okay. Please reach out as you are looking into this if you have questions or comments or concerns. And if there's anything that we can do to help you out, let us know. Just to be upfront, like my team right now is mostly focused on the Bootstrap provider, the Docker provider, anything else needed for Alpha 2 related to CAPI or Kappa. And then some of us are also working to make sure that Alpha 1 is as stable as it can be. So Jason's PR to do the retry and back off on for eventual consistency is a good example of that. So we are somewhat fully booked, but we can shift around a little bit if needed.
Yeah, so what I'll do is I'll go hire 8 people to fulfill my promise. Yeah, so I think we were kind of expecting that. We talked to Vince last week, and he pretty much indicated, yeah, like y'all are basically the only people who use the pivot in this way. So if like PR's welcome, and like we're cool with that. So we can take care of as much of this testing as we can, and then like when we come up with a design, we'll also implement that too. That's not too big of an ask.
Yeah, I would say priority number 1 is the investigation plus coming up with a proposed design so that we can review it, and hopefully the implementation won't be too bad.
Excellent.
All right, anything else before we adjourn? Doesn't sound like it. All right, well, thank you all for participating, and I will get this uploaded to the channel as soon as I have a recording.
Cool. Awesome. Thanks.
Thanks. Bye.
All right. Bye.